Okay, so we're back, and as you can see here, I've left it running for a little while, and sure enough, the score is currently 440 to 881. Needless to say, the AI is doing an okay job, but it's a reasonable way to test its performance over time versus sitting still. Also, this is a reminder to us that in addition to that net and having the paddle control the ball, in terms of how it's hit, and I'll walk you through that just next, this is a reminder too, we also need a win condition. We need a maximum number of points to earn, at which point we'll end the match and we'll show who's the winner and that kind of thing. But first off, let's get ball control going. And what I mean by that is right now when you watch the game, you'll see that every time the ball bounces off a paddle, it's just reflecting it. It's just exactly as if the wall was there, and if the ball's out of the way, then it's like there's no wall there. This has a few bad side effects though. The first of which is that it means that you as a player, or the computer player, have no influence on the path of the ball. That means that technically, as soon as you've touched the ball, you can actually extrapolate just looking at the lines where it's going to be and immediately start moving there. Now, secondly, you have no reason to take risks. You have no reason to try to hit it with the edge of your paddle. Right now, every time you get right in front of where it looks like the ball's going, you put your paddle right in the center of it and play it safe so you have maximum margin for error on both sides. It would be great if you have a way to incentivize the players, a simple, clear way to incentivize the players to try to hit the ball with the edge of their paddles, which is, of course, going to increase the chances they're going to be a little overconfident and miss. The way all that happens has to do with the angle that the ball takes after it bounces off the paddle. So let's look at where we're reflecting the ball when it bounces off the left paddle. So it's right here in the code. And you'll see all we're doing right now is we're reflecting the horizontal speed, and we're going to keep that portion. But we also wanted to have it affect the vertical speed of the ball. Ball speed Y. And the relationship between ball speed Y and the part of the paddle it hits, that again, this has been classically determined, it's been around for 35 some odd years, is when the ball hits the middle of the paddle, it'll go back in a straight line. That'll penalize players who try to play it safe by hitting it with the middle. The closer you get it to either edge of the paddle, the steeper an angle and the faster the ball is going to be. So, the further it gets, say if you hit it real close to the one end, it's going to go up and real steep near the top. If you hit it real close to the other end, it's going to real steep and down below. Hit it in the middle, it's going to go to a straight line and kind of everywhere in between. And there's kind of an easy way to think through this. We can do this with math instead of having to worry about segmenting the paddle into chunks or parts. Because we know we want it to go at a 0 vertical if it's at the center of the paddle, let's begin by subtracting the center of our paddle from the ball's current position. So I've got, let's see, var delta y. Deltas, don't get intimidated by the idea of delta, it's just a difference, equals the ball's vertical position minus paddle 1y, since that's the paddle that it is being hit by. So that, but then once again, whenever we want that center of that paddle, we want to add half the height to it. So this is just going to give us a plus or minus value for how far below or above the center of the paddle is. And if it's right lined up with the center, it's going to be 0. And we could actually directly set our ball speed y off of that, ball speed y. But the downside of doing so is that that number could be pretty big, right? Our paddle is 100 pixels tall. This could be up to 50. And a vertical ball speed of 50 is going to be pretty out of control. So let's instead dampen it just a little bit. Let's make it about a third of that range, which will give it a more reasonable vertical speed. And we can tune this number, play with it. Of course, I played a little bit ahead of time to guess that 0.35 works nicely there. And we can go back into the game and we'll show it. But first, let's hook it up for the right paddle too, so we can kind of see it from both sides. I'm going to paste it down here. Now, remember that when you paste it for the other paddle, you no longer run a Bayesian calculation on the player's vertical height, but on the computer player's vertical height. So we're going to replace paddle 1y there with paddle 2y. Saving that. So now I've reset the game, and what we should see now is that when you hit the ball near the edge of a paddle, it should get a vertical speed based on about how far you hit it from the center. And let's see if I can recreate that. So there we go. I hit it about kind of a little above the middle. It went up a little bit. If I hit it near the bottom a little bit, it'll go a little bit straighter. Now, one thing to keep in mind when trying to test this feature is it's a little hard to extend exactly what's going on, because remember that it's setting, there we go, I hit it kind of right in the middle. It's actually being based on where it crosses the line, or the total edge of the screen, not necessarily, there we go, right in the center, not the front of the paddle, since we're kind of ignoring the thickness of the paddle in these calculations. But basically, you should now have control over, like, okay, well, the player's up there, I'm going to shoot it down to the opposite corner. You can see that. I can try to have some deliberate action to interact with it. Or I can try to make a steeper shot. Ooh, boom. And that zigzag, of course, makes it harder to return. This incentivizes taking riskier shots with the ball and not just always playing it safe. But it's just a lot more fun. This is one of those things that oftentimes when people make a clone or a remake of one of these classic games, they'll forget this feature, and it's really instrumental to what makes this game work. Because now you have some control with some say over where that ball goes. So that's our ball control. Okay, so the next thing that our game needs is a win condition. Right now the score can just keep going up and up and up. And so let's look at where and how we do that in the code. We're already storing values for player 1 and player 2 score. We just need to look and see where do those values exceed a certain amount to play to. Like it could be 3, could be 7, could be 15 or 21, depending on the pace that you want your game to go at and how long you want sessions to be. Let's define a constant for that, just like we do for our paddle height and thickness. And that'll be good because once again, it ensures that like our numbers will stay in sync for how many points both players want. It ensures our code will be easier to read because we'll be able to see, is player 1 score greater than or equal to winning score is a little more clear than greater than or equal to 3 or 7 or whatever the number we might just type randomly into there. So I'll say const winning score equals 3 is a good starting value. Maybe we'll decide later we want a bigger one, which since it's right here will be easier to tune and tweak, but 3 is going to be easier for us to test. So I've got that number now. And where would it make sense to check the logic for that? I mean, conceivably, we could check every single frame that the game is being drawn, but scoring doesn't happen that often. It's really not necessary to check it every time everything's being updated in the game. It only really happens right before the ball gets reset, or as part of the ball being reset, where that means that someone must have scored on somebody. Well, let's look at where that's happening in our code. And the first thing I'll point out, kind of maybe done deliberately for point of illustration, or so I'd like you to believe, is that I'm adjusting score here after I reset the ball. Before it didn't really matter. Like, why do one before the other? We wanted two things to happen. We wanted the ball to reset, and we wanted the score to be adjusted. But if we want to make our win condition check part of the ball reset logic, then we should add to the score before we call ball reset, so we can base the decision on whether or not to end or reset the scores in the match on whether or not one of the scores has reached enough points. Does that make sense? And here's one of these places where, again, earlier on we could think of it as just being, we need both of these things to happen, order doesn't matter, but suddenly the order matters. We have to add score before to reset to make sure that we're calculating for the most recent points. Because that's sort of this thing that might not be obvious if we look at this code later, that would break something if we change that order, let's put a small comment here, must be before ball reset. So at least calling attention to later, that's the case. And we won't accidentally flub up and mix it up the other way. And again, that's one of the main uses of comments, to leave notes for future us, so we don't come back and mess something up, not realizing how important something was when we made a little subtle change back when we were working on it. So we've got player 1 and player 2 score being increased. We have winning score as a constant. And inside ball reset, let's just take a look at the top of that function and inspect whether player 1 score is greater than or equal to winning score, or else, these are OR bars, they're much like the double ampersand and also, except kind of the opposite. Player 2 score is greater than or equal to winning score. And what I mean by they're like the and also symbol, remember these were and also, if we use the and also, this would mean that both scores would have to exceed 3 points, or meet or exceed 3 points, for this to happen. By using OR bars, and those are, you see where like the backslashes are on your keyboard? Shift, that key gives you these vertical bars. This means or else. And in this case, either one of these can be true for this if statement to trigger and activate its insides. So inside there, if one player or the other has earned enough points that the match is over, let's go and reset both scores. We can do something a little more elegant in a moment to acknowledge who won, or that someone even won at all, but this will be a good starting point. 0 both scores if either player has exceeded the winning point total. And we can see already when I go back to our program, the need for this is pretty dramatic, because while it ran in the background, our scores became 84 to 86. All right, well, let's reset that. Now that we've saved their text file, as always, make sure you save your source before you refresh in the browser. And let's just let the AI computer player get a few points on us and see if it works. 1 point. 2 points. Now, if it worked, we should see, when he scores the third one, there we go. Both scores zeroed out right as his score, or her score, reached 3. Now, in order to test scoring on the other player, we could sit here all day trying to play the game better and better. I'm going to say that's not really a great use of your time. Instead, let's go back to the code and temporarily turn off computer movement. remember that these comments, the 2 slash marks that we use to give ourselves notes, to tell the computer don't try to run this code, can also be used to say temporarily ignore this. It'll still be there, easy for us to switch it back on. We won't lose track of how it's typed or where it goes, but saving that change and refresh the browser, and now the computer player will sit still. Hopefully I can get these points. There we go, 2 points for me. If this third point scores, we're going to find out if it worked, and it did. Both scores now zeroed back out. So okay, so we have a maximum score happening, although we're not really being very, there's not a lot of finesse here, right? It's just happening and then brutally, instantly resetting the scores. If you're not watching right when it happens, you're going to miss it altogether. So let's make sure the game acknowledges that somebody won by pausing the action until maybe we click to bring the game back into action. Oh, let's go ahead and take off that comment that was disabling the computer player from being able to play. Let's have a variable. And when that variable is set to true, we'll have the game kind of in a locked title screen or between rounds mode. Okay, var showing win screen. So far, you've only seen us setting values to whole numbers, 1, 3, 14, 10, 250. You can actually set these also to true and false, which makes them very easy to signal to yourself elsewhere in the code whether or not you are currently showing the win screen, because we don't have to check like if showing win screen is equal to 1 or is greater than 0. We can just check if showing win screen. If you're coming from another programming language, you may be used to seeing things like bools or booleans as a way where you define a different type of variable than what might be an int or a float than a number. But in JavaScript, they're all var. And based on how you assign the value, JavaScript figures out for you, okay, this is going to be a true-false value. This is going to be a whole number value. And it figures it out as we go. So that's what we're going to do for our win screen. And we need to check and see where those scores get exceeded. And let's flip it to true there. And by flip it to true, I literally just mean we just tell it literally true in all lowercase. So it started off as false. It became true there. While it's true, let's skip the move everything code if we're currently showing the win screen. And by skipping it, we can use an if statement. So if it's currently true, we don't actually have to explicitly check and see if it's true. That's what this is doing, i.e. we don't have to say equals equals true. Then return, and return is just a way to bail out of the function prematurely. Nothing else in move everything will get a chance to even happen if this return gets hit. We can do the same thing in draw everything. So if we're on the title screen, we won't even see the paddles or anything else. Maybe we'll leave that blanking line in, that background that blacks everything out. And while we're on the title screen, let's show a message that indicates what's going on. Let's get this fill text from below. If we're on the title screen, let's just say, click to continue. Click to continue. And I see I lost my parentheses right there. Okay, so it's got 1 point on me. It's got 2 points on me. As soon as it scores at third, oh, now we're blacked out. Now the problem, we're not seeing the text. Remember that we're using fill text, which is using the previous fill color, which was set to black by color rect in our source. So we will need to fix that. We can come down here, borrow a fill style call. We could make ourselves a separate color text function if we'd like, just like we did for color rect and so on. But just to get this working, let's check and see. If I set this back to white, and 1 point scored, 2 points scored, and this should be our third point. There we go, click to continue. Now we can't yet click, but we'll hook that up next.